All right, guys, in this video, we are going to be doing LeetCode code problem number 1762, buildings with an ocean view. This is a medium difficulty array problem, and let's take a look at the prompt. But before we do that, this video is actually taken directly from our latest iOS interview mastery course. You guys can check that out on the new website at appstuff.io. We got a brand new website here, guys. I'm super excited about it. The link for this is in the description, and you guys should definitely check this out if you want more interview practice with data structures and algorithms. And as you can see, we also have a full and complete data structure and algorithms course that is a deeper dive into data structures and algorithms. So you guys can check that out as well. The link for that is in the description. Now let's go ahead and get back to the problem. There are n buildings in a line. You are given an integer array of heights of size n that represents the heights of the buildings in the line. So we're going to get an array of integers, and each item in the array represents the height of a building. So how do we determine if a building can see the ocean or not? Well, the ocean is to the right of the buildings, as we see here in this input example, which we'll break down in a second. A building has an ocean view if the building can see the ocean without obstructions. Formally, a building has an ocean view if all the buildings to its right have a smaller height. Return a list of indices that are zero indexed of buildings that have an ocean view, sorted in increasing order. So let's take a look at these examples to break this down. So if we get this input of these building heights, right? The ocean is to the right of them. We want to return all of the indices or indexes, whichever one you want to say, of the buildings that can see the ocean. So we see that building at index 0, 2, and 3 can see the ocean. So why is that? Well, 1 can see at the 3 index can see the ocean because there is nothing to the right of it but the ocean. So that's where we get index 3. Index 2 can see the ocean because this building is larger than the only building to the right of it, so therefore it can see the ocean. 2, or the value at index 1, cannot see the ocean because it is blocked by this building. And last but not least, at the index of 0, 4 is taller than all the buildings to the right of it, therefore it can see the ocean, and this is our expected output. Here we see that all buildings can see the ocean because each one is taller than the next. And here, the only building that can see the ocean is the last one because all of this last building here is taller than all of the previous buildings. So that's the problem, guys. Let's go ahead and see if we can dive into a solution. So as always, I want you guys to pause the video, try to think about this, at least try to think about how you would solve it and how you would start articulating your solution to the interviewer. Talk out loud, think through the problem, and come back to the video and maybe even try to implement a solution on your own, and then come back to this video. Alrighty, so as always, I like to get started with defining my function, guys. So I'm gonna make a function called func find buildings with an ocean view, and look at that, Xcode hooks me up there, man. So we have our function defined, and it takes in some integer array of heights and returns an integer array that will represent the indices of the buildings with an ocean view. So guys, one way of doing this is the brute force approach, right? So we could use a nested for loop to look at the current building, loop through the rest of the items or the items to the right of that building, and then calculate, which building has, how many buildings have an ocean view. So I always like to start with the potentially non-optimal solution and improve it from there, right? Depending on how much time you have in an interview, this can be good to do. I actually received this problem in my interview for Meta, and I did start with that brute force approach just to make sure I got something down. And then I improved my solution and explained why it was better. So that's what we're going to be doing here. So I'm going to create my result array. And we've already sort of talked through how we want to solve this problem with brute force. We just need to implement the solution now. I'm going to say return result. So let's go ahead and get our nested loop situation set up. So I'm going to say for I in 0 up to, but not including heights.count. And then we're going to say for j in I plus 1 up to, but not including heights.count, right? So let's break down looking at the first item in this heights array and what the nested loop would look like and what we want our logic to look like in order to get the desired solution here, guys. So my main loop is going to start at 4. So I'm at index 0, and then it's going to fire off the sub loop first thing, and it's going to look at these subsequent items in the array. And essentially what I want to do is say that if I ever see a building that is taller than this current building that I'm looking at in my main loop, then I know it does not have an ocean view and I need to stop there. If I do get through the entire array without seeing a building taller than the building I'm looking at currently, which in this case is 4, then I know that I do have an ocean view and I want to append that result. So here's what we're going to do. We are going to use this Boolean property. We're going to say var has ocean view, and we're going to set it to true. And we're going to, in this array, at each iteration, check and see if heights j is greater than or equal to heights I. We're going to say has ocean view equals false. And then once this loop completes, we're going to say if has ocean view results.append the index of I, right? And we can actually go here and improve this a little bit, not that it really matters, but, and say break, because we know that if we see a building that's taller than us, we don't need to keep going through this sub loop, right? We just set this property to false, and then if after this loop has completed, whether we break from it or we go through the whole thing, then we know that we want to append that element or that index to our result array. So I think that looks pretty good, guys. And what's interesting about creating this has ocean view property within this for loop is every time the loop restarts this or goes to the next iteration, this will default back to true. That's important to understand here, because if we put that here, then that value would persist in each iteration of the loop. So if I set it to false one time, it would stay false. But putting it inside the main loop there sets it to true, or resets it to true every time the loop restarts. So that's a cool little technique there. Let's go ahead and test our solution now. So we're going to grab our heights here. We're going to say let heights equal that. And we're going to say find buildings with ocean view heights. And we're going to run our solution in this playground. And we should see that we get 0, 2, 3, which is the expected result. Let's go ahead and do this guy here. Run it again. 0, 1, 2, 3, which is the expected result. And let's do this guy. Boom. And run it again and see if we get just 3. And perfect, man. So this is, albeit a suboptimal solution, it is still a solution, guys. So you might be asking yourselves, like, why did you do a suboptimal solution here? Well, the reason for that is it gets a solution for the problem down, right? So worst case scenario, you still solved the problem. A mistake I've seen candidates make when giving interviews is trying to find the most optimal solution right away and not being able to get it right completely. And then they end the interview without having a working solution to the problem. To be clear, it is better to have a working suboptimal solution than a non-working potentially optimized solution. So that's point number 1. Point number 2 is if you are on a time crunch and don't have time to get the most optimal solution down, you just go with whatever you can do in the given time frame that you have. Once again, a solution is the priority. All you would need to do is explain to the interviewer why this is a suboptimal solution. So let's go into that next. We would say this is suboptimal because we have a quadratic runtime here. We have a nested for loop, and this would not behave well at scale. So that's why this solution is suboptimal. We do have linear space complexity, but we have quadratic runtime complexity. So that's why this is bad. So guys, I'm gonna say here, brute force to make that clear, and we can get rid of that function call. So next up, I want us to try to find an optimal solution. So let's go ahead and copy this line of code for our function and just remove the brute force. And let's think about how we can optimize our solution. So the optimal solution for this does have linear runtime complexity and linear space-time complexity. You could even argue that because we have to return an array, that doesn't even really count towards our space complexity, because we have to return an array no matter what. But the goal of this problem is to get this to work with a linear runtime complexity. So that's what we're going to do now. Let's start with what we know, right? We know that in this scenario, the ocean is to the right of the inputs, right? So I know that automatically the last item in the array will have an ocean view. So that's something that we can use to our advantage. And then it's like, okay, well, naturally after that, I would probably go and check the one before that and see if that has an ocean view. And then in this case, that's yes. And then I would check the one before that and the one before that. So what we're doing there, without even really realizing it maybe, is working through the array backwards instead of forwards. Because when we did it from a forward direction, we had to use this brute force approach to check all of the items after the first one. Well, because we know this is to the right, we can actually loop through this thing backwards and just do a single pass and calculate the buildings that have an ocean view that way. So that is a much more optimal solution because we only do a single pass through the array and it will achieve that linear runtime complexity for us. There is a little bit of trickiness involved in it though. We are going to have to keep track of the tallest building we have seen up until that point, right? So as we loop through this, we need to keep track of sort of a running local max value or local tallest building value that will help us gauge whether or not the other buildings can see over it to the ocean. So what we would do is say, hey, at this point in time, the current max is 1, right? So, and we know that 1 will have an ocean view no matter what. Then I get to 3, and it's like, okay, now I have to update my maximum value. The tallest building I've seen thus far is 3, but 3 is taller than 1, so I know that this also has an ocean view. So this is where the max comes into play. When I get to 2, do I update my max? No, because the tallest building I've seen up until that point is 3. Therefore, I know that 2 is blocked by 3, and it won't be able to see. And then I get to 4, and I update the max to 4, and I say, because that's taller than the previous max, which was 3, and then I know that I can subsequently add that to my buildings with an ocean view. So let's go ahead and do this now, guys. So we're still going to create our results array and return that result. And we are going to use a pointer here to loop through this array backwards. So I'm going to create that pointer and I'm going to call it I and say it's equal to heights.count minus 1. And then I'm going to create another variable to keep track of my max height or my tallest building. And we're going to set it to 0. So now I'm going to say while I is greater than or equal to 0, and you guys don't have to use a while loop here. You could use the stride function in Swift. You could also reverse the array and loop through it there. But note that reversing does require, I believe, a linear runtime complexity to perform that operation. So the other option you have is saying like for I in stride from like blah, 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 right? Something, yes, stride from to by. That's another way you can loop through something backwards. But I'm using a while loop because it's honestly just easier to write. So I'm going to say if heights I is greater than my max height, result.append I. And then I'm going to say my new max is max height is equal to the heights I, right? And then I'm just going to decrement I. Pretty simple. So I'm pretty sure that's all we're going to have to do. Let's just go ahead and go through our loop iteration by iteration and make sure it makes sense. And let's start with this example up at the top. So let's see, guys. My max height is 0, and I'm saying, is 1 greater than 0? Yes. So I'm going to append the index there, which in this case is 0, 1, 2, 3, because remember, we're using an indexed pointer here. And then I'm going to go to the previous item right here and set my max height to 1 before I do that. So right now, max height is 1. I always do these sort of comments and go through the loop iteration by iteration just to make sure it all makes sense. And you should do this in an interview too, because you don't usually get access to a compiler and you just have to go through this with the interviewer yourself. So you don't have the option of just running your code and seeing if it worked. So next up, now we say is heights at I, which in this case is now 3, that's the height, greater than my max height? Yes. So now I append that to my result. So now I believe my result is what? It's, let's see. Right now it's index at 3 and 2. Yes. Okay. Now max height is 3. Or we have it up here, right? And then I minus equals 1. So now I is looking at 2. So we go through this guy again. Is 2 greater than 3? No. So it doesn't care. It just skips that whole thing and it decrements I. And now we're at 4. Is 4 greater than 3? Yes. Okay. So now we append index 0. Max height equals heights I. So now that's 4, but we're done with the loop, so we don't care. So an interesting thing, however, is that we have our array, our desired array in reverse order. So we would actually need to go here and say result.reversed. So this to me is a optimal solution. We have decreased our runtime from quadratic to linear because we're only doing a single pass. This will also just result in a linear runtime, but I think it's going to have to be O2n, right? Which is still way better than ON squared, which is what we had before. So now it is time to check this in LeetCode, guys, to see if we got this right. So let's see. I'm going to pull up this problem and get our code pasted in there. Paste, submit. And check that out. Absolutely awesome. All of our test cases passed. We ran in 0 milliseconds, beat everybody because we're ballers. Let's look at our complexity. Linear, perfect. Space, constant, perfect. Love it, man. All right, guys, that's going to wrap it up for this video. Hope you guys enjoyed that breakdown. We'll see you in the next one. Peace.